Okay, they like to do this. Okay, so this is the overlying pattern of minima and maxima that I tried to draw in the previous video, obviously utterly failed. Okay, notice that the diffraction, this is due, this sort of dotted line there, that's due to the diffraction of one of those slits, okay, or the other one, right, you know? Okay, and then this is due to the two slits interfering with each other. So this is the diffraction pattern. This is the Young's double slit pattern, those little intensity maxima there. Okay, notice that that this guy occurs right at the 1, 2, 3, 4th order. Okay, so what you can do, basically, what they're trying to say is, what is the angular separation between the central peak and the missing peak? We can do this, right? We can do, there's a lot of ways to do this, right? But n lambda is d sine theta. Okay, we can do that, right? And we can say that this is our 4th order. We know lambda from the previous page is what, 633 nanometers. We know that this is 0.300, and then you can figure this out, right? Okay. I think they get it in radians, okay? The other way you can do it, if you just want to cut to the chase, okay, is that if the distance between these things is 9 millimeters, as it said on the previous page, what they say on the previous page, by the way, is that this is 4.5 millimeters from here to here, right? If that's 9 millimeters, then this will be 1, 2, 3, 4 times 9, right? 4 times 9 millimeters is that distance, right? And then the angle essentially is just that distance. So what, 36 millimeters divided by the distance to the screen, right? Which is, do they tell us that? They don't tell us that. Let's see. Oh no, we know the distance to the screen. Yeah, we do. All right. Yeah, we just figured it out. Sorry. Okay, so the distance to the screen. So you can just divide that. I think that's the number between 4 and 5 meters. Okay, so so that's how you do this guy, right? Find that, and it's a number. If it's in degrees, it's between 0.4 and 0.5 degrees. Their first answer, though, is just radians. And literally, they just do this. They just divide this by this, and they get an answer that they round, in my opinion, unacceptably, because they base it on a rounded thing. And then they say, I think they say, allow this answer if they didn't round, right? It's like, anyway, okay. Deduce in millimeters the width of one slit. All right, so now you know what that angle is, right? You just figured out that diffraction angle. That's going to be the angle, right? And that's going to be lambda over b, right? Now, really, we should be going, sine of that is whatever. Make sure if you do sine that you are in radians, right? Okay, and then we know lambda, and then b is what you're trying to solve, okay? Anyway, it's what is it? It's some fraction of, it's less than 1/10 of a millimeter, but just barely less than 1/10 of a millimeter. Make sure you answer in millimeters, okay? A millimeter is just 10 to the minus third meters, right? Okay. Yeah.